Okay, everybody, good afternoon. Give me a nice like if you guys can hear me. Hopefully, you guys can hear me. And if so, give me a like. Okay, the likes are coming in. So that sounds great. Now, let's go to the browser here. I think you guys know we did grade your exam and I did post your test 3 solutions. So I want to remind you guys here, you got your answers and you got your solutions. So you can check where you went right, where you went wrong. Okay, so double check, ladies and gentlemen. We're also going to check our internet speed. So hopefully it's going to be just as good as what we've had all day long. Let's double check. Okay, so the download speed is actually better than earlier today, slightly better. And the upload speed is comparable. It's the same. So, you're going to have an excellent experience if you post your YouTube to HD. So please do that. And, we'll be good to go. So today, what we're going to work on, I'm still in the browser. So let's go to statistics here. We're going to look at statistics lecture normal. There we go. We're going to work on this here. So statistics lecture 12. This is the normal distribution. And, I can kind of stick with something that's kind of, it's kind of interesting. Maybe we're going to stick with IQ scores. I'm going to try that out. Okay. But it doesn't have to be IQ scores. There's a lot of normal distribution questions we could work with. So here's what I'm going to start off today with an example of how to work with the normal probability distribution. And I'm going to say here, for example, IQ scores are normally distributed. Now, what that means is when they first say this, we'll go through that, with a mean of 100 and a standard deviation of 15. Now, notice what I'm going to say. What percent of the population has an IQ score that is, I'm going to say this is question 1. How about this? That is between 90 and 125. So, I'll give more questions in this, but we're going to kind of go through how you handle a normal distribution question, and you're going to follow a procedure. But I first want to point out that what are they saying? IQ scores are normally distributed. So what that means is you're going to let X equal an IQ score. And the second you know that this is normally distributed, you're going to draw a picture of a normal distribution. So really the first step that I tell people here, and I guess you can follow these steps, you can say step 1, draw a picture of the question. So here's your first step. Now, in order to draw a picture of the question, you know what X represents. It represents IQ scores. And you're going to draw your bell. And in the center of the bell, always put your mean. So remember, I'm going to write this here. This is mu. This is a normal distribution. So this real number line represents X values, by the way. And in this case, since they said the mean is 100, they told us this. The mean's 100 and the standard deviation is 15. right? Because they said mean of 100, standard deviation 15. So they gave us this information. So here's what we want to do, right? We haven't drawn a picture of the question, but this is kind of where we're starting here, because the question is going to be, what percent of the population has an IQ score that's between 90 and 125? So what that means is that 90 is less than or equal to X, which is less than or equal to 125. So we have to find 90. And if the center here is 100, 90, ladies and gentlemen, is to the left. So I'm going to do this picture here. Okay, so we're going to say here's where 90 is, because it's to the left of 100. And, you know, maybe you say, well, can I erase that? Well, okay, so here's the center, it's 100. 125 is further to the right, over here. Okay, so remember this. This is where my mu goes. Center is 100. Now they want to know what percent, here it is, right? What percent of the population has an IQ score that is between 90 and 125? So they're talking about the area right in here, ladies and gentlemen. Let's change the size. Area between 90 and 100 here. So, yeah. Anyway, maybe it should have been bigger, but then we get, yeah, should have been bigger. I'll make sure I change the size. If I do it now, it's not going to be. So they're going to want to know what percent of the ballot is shaded between 90 and 100. So here is what I'm saying. Here's a picture of the question, and you do this every single time, I guess, right? And so that's step one. They want to know, you know, what percent of the population, you know, has an IQ score between 90 and 125. Now, you might say this looks familiar, and I'll say it does. So I'm going to go through the steps here that I traditionally go through, and then I could show you how to do it with the TI. So this is my first step. This is drawing a picture of the question. Okay, so anybody have any questions on this part? Sorry. All right, you guys have any questions on that part? That's a picture of the question. Now, the second step is I'm going to say to you, you're going to convert the normal distribution, which is what you're looking at in step one. That's a normal distribution question, to the standard normal distribution. Okay, so if your normal distribution is represented by the random variable x, the standard normal is z. That's the table you guys were working with last time. So this is a conversion step. So what I'm going to do here is I'm going to copy everything you have here. And copy that. We're going to paste it here. And then you say, how do I go about this process of converting, right? So how do we convert a normal to a standard normal? And I'm going to use another color here. It's the standard normal distribution. So the standard normal distribution is a z distribution. You do that by using this formula. Z equals x minus mu over sigma. Now, that's something you guys should remember. That's your z formula. That's the z value. Remember this formula? And in this case, we know mu is 100 and sigma is 15. So that formula that we use, the conversion formula, is x minus 100 over 15. So this is what we use, ladies and gentlemen. Every x value you plug in right in here, and it gives you a corresponding z value. That's the conversion. So we're going to convert this distribution. It's no longer going to be x. It's going to now be z. So that bow is going to be a standard normal curve. We just have to find what every one of these values becomes as a z value. So there's going to be a conversion step here using this formula. So I want to start off with the center, mu. You see, since mu is 100, okay, mu is 100, plug in 100 for x. So what you should see as a z value, you get 100 minus 100 over 15, or we get z will be 0 over 15, and the z value is actually 0. So your center mu, even if I said, wait, that's going to be true in general, and I'll say yes, the mean, whatever you're dealing with, will always be 0 as a z value. So the mean becomes 0 always. And that should make sense, because if you looked at the table we worked on last week, 0 was what we had for the mean for the standard normal distribution, for the z distribution. So we're converting to a z distribution. Okay, you guys okay with that? And we're going to have to convert not just the center, the mean, we're going to have to convert this data value of 90, and we plug that in. And when we plug this in, we're going to find this conversion. Now we're going to get a value here. Now let me go to the TI, because what you're looking at is converting 90. So let's go to TI and we say, okay, TI, this was from earlier classes. Let's get rid of that. We're going to say, okay, I have 90 minus 100 divided by 15, the standard deviation. So ladies and gentlemen, this is the z value. Now, z values are going to be approximated always, always, always to the nearest hundredths. So negative 0.067 here to the nearest hundredths. Here's what you guys want to do, right? That's 0.6666667. The nearest hundredths is going to be right here. You look at the digit to the right, and because it's a 6, we add 1 to the digit in the tens position. So we add 1 here. So this is, I apologize, we don't approximate to the tenths. We approximate to the hundredths position. So find the digit in the hundredths. This is going to be tenths, if we can get the right tool. Tenths, hundredths. There we go. So the 6 is in the hundredths. Look at the digit to the right. And if that digit's a 5, 6, 7, 8, or 9, we add 1. So we're going to add 1 here. So we get negative 0.67 as a z value. So we're converting, ladies and gentlemen. 90 is really going to be negative 0.67. So all that's left is converting 125 now. So you repeat the process using your conversion formula. That's a 125. And so when I go to the TI and say, let's convert, we have 125 minus 100 divided by that 15, and you're going to get a value that we convert again to the nearest hundredths. Okay, so that's 1.666666666 forever. So we're going to try that value here, and notice that value is positive. So we'll have z equals 1.6666 and so on, going to the nearest hundredths, right? The second decimal. You look at the digit to the right, and sure enough, this will be a positive 1.67. So ladies and gentlemen, this is our conversion here. So this is 1.67 now. We have converted every x value to a z value, and you always approximate this to the hundredths. And that's our step 2. So I want to say that this is equivalent to asking somebody, what's the probability that z is between negative 0.67 and positive 1.67, just like this question is asking a probability of being between 90x and 125. Okay, so I want you guys to just note that. So let me put the note down here, or a fact, or let's just put that as a note, that the probability of 90 being less than or equal to x is the same as this negative 0.67 less than or equal to z less than or equal to 1.67. But here we have a x value and here we have a z value. So we converted, and this here equals a probability. But if they ask percent, you just move the decimal. Okay, so for percents, we just move the decimal. And so now you might say to me, what do we do now with these things? How do we go about, the rest of what we're supposed to do? And I'll say to you, very simple. You play the game. Here's what you play. What percent of the bow is shaded? So we play the game what we played last week. Okay, you say, where do I play the game? Right here. So let's copy this. I'm going to copy this. And I'll say step 3. Here's what I describe in step 3. Right? Step 3. Use the z table to determine the percent of the bow that is shaded. And, that's pretty much the whole process. What percent of the bow here is shaded? We did this last week. So remember what we did last week here. We need the left portion. We need the right portion. We're going to use the z table for the left portion and the right portion. We're going to use that concept known as symmetry. Okay, we're going to put this symmetry concept also at play, right? So we have to remember the idea of symmetry so we can use that z table and find the answers. So here we go. If you guys remember the z table here, right? So for the first area to the left, tell me which row do you guys use? We're looking at a z value being 0.67. Let's see if you remember from last week. Z being 0.67. We need a row, right? And we have to add it with a column. So what row was this last week? It was row 0.6. And then this is my column out here, 0.07, if you guys remember. So I need to find the z value in row 0.6 and column 0.7. If I can find that value, and I want a highlighter, row 0.6, column 0.7, you got to look at the table, and you say, Mr. Judge, where do I find the table? And I'll say, go to the browser, Math 227, formula card and tables. Ladies and gentlemen, here we go. Row 0.6. Okay, so let's see if we can make that big. We need row 0.6 and column 0.07. So take a look at this, and I'll tell you what I see. Row 0.6, column 07. Okay, 7's the third one from the right. 0.2486. Did you guys get that? It looks like Maria got this, right? 0.2486. That's what I got. Thank you, Maria. So if we go to the iPad, and I found that. So remember what this means. That means that this area is 24.86%. Yes, this is a probability value, but I moved the decimal. So the left portion here, because of symmetry, I don't need a negative z-value table. I just use the positive z-value table. 24.86%. Now we have to find the other area. Okay, so what we just found was area that applies from negative 0.67 up to 0. We now have to find the area from, and I'll change the color maybe, right? So here's going to say we found that orange. Can't even see it. We need this green. Can't even see that, but okay. So we need the area. We need a row. We need a column here. So if I said to you, let's do the same thing now. My other z value is 1.67. The row that is going to be those two values, 1.6, and then the column is 0.07. So here's my row again and my column. I need the 1.6 row. So I'm going to have to look for 1.6 and then the 0.7 column. So whatever value is in the 1.6 row, 0.07 column, ladies and gentlemen, we're going to find that area. So we go to the table and we say, okay, where are you, table? You're in the browser. So I can find the 1.6 row. You know, it's right in here, the 1.6 row, and then 0.07 looks like it's this value right here, right? 0.4525. So 0.45, looks like Marta says, yeah, 0.4525, if you guys can see that. And that's about 45.25%. So let me write this down in the iPad. 0.4525. There we go. That's what we should see. And remember, this represents, right, 45.25%, ladies and gentlemen. There we go. But we need the final answer. So even though this is a probability, we're going to write the percent. So P can be probability or percent. As long as you know the difference, it'll be 24.86 plus 45.25. Okay. And if I get out my TI, we can say TI, can we add 24.86 with 45.25? And ladies and gentlemen, the final answer is going to be, as a percent, 70.11%. Remember, they asked for percent language. This is equivalent to 0.7011, and that's a probability value. I guess you guys can't see that. Let me write this down. 70.11%, I wrote down right in here, because we added 24.86 with 45.25, okay? And I'm also notating that this is equivalent to the probability answer. Just move the decimal. So you got the probability and you got the percent. And ladies and gentlemen, this is the process that we use. The only thing I taught you guys today that's new is step 2, the conversion step. This is the only thing that's new, and putting it together as a process. So ladies and gentlemen, this is what you guys are going to be able to do. This is why we went through the idea of what percent of the bell is shaded. Okay? Now, hopefully you guys are, let's ask you this. Okay, we got a question here. On the test, which answer should we write on the answer sheet? That's a good question, Agina. If they ask you for probability, write the probability. If they ask you for percent, we're looking at it right here. If they ask you for percent, give the percent. So here, percent. Down here, probability. So essentially, you give them the answer that they asked for. And in this example, they asked for the, percent. So I start off with percent because that's the language in which we discuss things, We don't really talk about things in terms of probability, unfortunately, Like we say, oh, there's a 70% chance of rain, right? So it's like, okay, I know what that is. 70 out of 100, And we don't say, oh, it's 0.7011 chance of rain. So, I start with the language of it, and then I, remind you that just move the decimal and you get probability. So there's just a relationship between probabilities and percents. All right, now this is what I was getting at. Is there anybody here? Hopefully you guys remember I asked you guys to do the following. You can use the TI calculator. Okay? And you could use that even online if you had, what is it? There's a free trial version. And we talked about that. Yeah, eventually, Maria, we will. Eventually, yes. So I want to show you guys on the TI, and if I go to the browser here, so I'm going to go to this browser, and here's the deal with the browser. You go, okay, where's the browser, blah, blah, blah. What are we looking for? Oh, the transition, right? Statistics transition, normal distribution. This worksheet, right? It's, I don't know, 50 pages, 70 pages. I have no idea. So I want to show you guys this information and how this works. Boy, look how long, even with our excellent download speed. All right. I want to go through some of this procedure. I did document the procedure written down. It's in your text, ladies and gentlemen. We have this for you. So let me find it. See, I go through this is what we talked about last time. Let's find the procedure. Okay, look at this. This is normal. If the mean is 0 here, ladies and gentlemen, let's go back. If the center is 0, they're talking standard normal distribution. Okay, so I'm looking at something like this. This is a procedure I want to use. They had different values, but this example, did I even give the answer? No, I didn't give the answers. Good. I showed people how to do this with the TI. So here's my procedure. Press the vars function or the distribution menu, look for normal CDF, and then click enter. So we have normal CDF. So let's go back to the iPad. And let's remember what we're trying to do. They're talking about a Z distribution. They're talking about this right here. Okay? And in fact, I should say they're talking about, I put it in our note somewhere in the note. Yeah. They're talking about this right here. How do you find, this answer there, which is the same as my picture right here. So I'm going to show you in the TI. Let's try it in the TI, right? So what they said was go to, clear that, second distribution. It's really the distribution. Normal CDF, number 2. Now, the lower value, the smaller value, which is to the left, that's going to be, put the negative 0.67. You're reading this left to right. So that's the lower Z value. The upper Z value in our example is 1.67. Now, notice the mean is 0. Standard deviation is 1. Oh, I guess they're talking about the standard normal. They are. So you can just simply paste this, press enter again. And what do you guys see here? Does anybody notice anything interesting? What do you guys see here? Is that the same answer? Is that its probability value though, 0.7011, But could you actually convert this to a percent? Isn't this the same answer? So I'm showing you, ladies and gentlemen. Thank you, Najina. It's the same answer. I don't know. Hopefully, you guys, if you say, Mr. Judge, I can't buy the calculator, I'll say, well, rent it free. Not rent it, I'm sorry. Get the free trial version for like 90 days, 100 days. I don't remember. You know, on the website I showed you guys. All right, you guys okay with that? All right, and then it gets even better. You say, what do you mean? How could it get better than this? Go back. The iPad. Remember, originally, it gets so good. Remember, this is the original question. This is new. Look at the original question. And this is an X distribution, ladies and gentlemen. This is a normal distribution. This is X, and it's between 90 and 125, where the mean is 100 and standard deviation is 15. It gets even better. So if I go to the TI, and I'm going to use the same concept. Go to distributions, go to the normal cumulative density function. There we go. The lower value here, we could have done this from the beginning, 90 down to, that's the lower value, up to 125. Now my mean is 100 and the standard deviation is 15. This is not the standard normal. This is the normal. Press enter. Uh-oh, what happened? We got a slightly different answer. Anyway, use the z-value. So forget what I just showed you. We're not going to go that route. So it doesn't get as much better. Looks like there's a difference there. So I only inserted the upper and lower value, and I got the same answer. Well, take a look at mu. The mu had to have been 0, and sigma had to be 1 by you know, in this example. So it looks like they want you to, let's just go get the z values. The upper value is on the right. Yes, you're reading this this way, because remember this here, if I read it left to right, anything left to right, and you want to read left to right, this is the lower value, which is smaller, and this is the upper value, which is larger. And that's how they interpret this. Okay, you're reading it left to right. Lower and upper. All right, so let's go about it with that. Okay. So that's my first question. I'm going to give you guys another question. Question 2. We're going to go through this process again. They're going to say, what % of the population has an IQ score that is at least 115? Okay, let's do this process. Draw a picture of the question. This is an IQ score. The mean is 100. This is the same question. So I have to understand, I haven't drawn a picture of the question, at least 115. Where would 115 be in relation to 100? Is it to the right or is it to the left? Remember, this is a real number line. Larger numbers live to the right. So 115 is to the right of 100, ladies and gentlemen. Now, at least means 115 or more. So we're going to need to shade this right tail. And if I were you, that was weird. We're going to need to shade this right tail here. Okay. And I would even write this down personally. It's a right tail. So what you can do is the right tail procedure. But remember, this is a normal distribution. This is X. We need to convert it to the standard normal. I already have half the conversion. The mean is always 0. So we need to know what is 115, right, as a z-score. So as a z-score, go to your conversion formula, right? The conversion formula is z equals x minus mu. In this case, it's 100. Standard deviation is 15. You're going to convert 115. So z will be 115 minus 100 over 15. And I don't need a calculator for this one. This is 1.00. Because we write this as a numbered in the 100th position. So my z-score here is 1.00. So here's the picture I usually draw. I draw my x values, and below I put my z values, and now I play the game. You say, what game? What percent of the bow is shaded? That's the game we play. What percent of the bow is shaded? This is a right tail. So if anybody's awake, we need the percent that's here, right? We don't know what that is. That's missing. So last week we said take 50% and subtract what's missing. This is what we do for every right tail. That's going to give me my answer. We just have to find right in here, again, what's missing here. That's the key. And this is where the z-table comes in, because the z-table answers questions from 0 to a positive z value. This is why we found that. So this is where we use the table. So remember the table here, right? We say the z value is 1.00. This is going to be a row plus a column. You say, what row? It's the 1.0 row. And then this last digit is the last digit in the column, but the first one's going to be 0. So, I did it with colors last week. I said, okay, here's 1.1. There's your row. And then I said this last value here is that 0. And here's really what I'm saying, that 0. So to use the table, and some of you guys are going to, because you don't have a TI that does this, and you didn't actually get the free download. That's fine. I'm going to show you how to do this without it. So we have the right row, 1.0 row. Let me get the right color highlighter. 1.0 row, 0 column. We want to know what z value is actually there. So let's go to the browser. And you guys already have the procedure, so I'm going to go back and make sure we get the formula sheet. We need the 1.0 row and the 0 column. Look at that first column is 0. So here's what we're looking at. So you can actually see it here. Anybody want to tell me what is in the, it looks like you already did, right? Maria gave the percent answer. It's below her answer. It's 0.3413. So Maria gave the percent answer. Jocelyn is given the probability version. We know the difference. Let's go back to the iPad. And you say, does that mean what's missing right here is 34.13%? And the answer is correct. Does that mean I take 50 and I subtract the 34.13%, and I'll say yes? And so I'm going to remind you what percent of the bow is shaded. Put your answer. Right, so go to the TI, and you can say 50 minus 34.13. And yes, you get 15.87%. So there you guys go. Okay. 15.87%. Yes, Maria, you're fine. Yes, Alexandra, you're fine. There you guys go. This is how you go about getting this answer. 15.87%. We have it right here. What do you guys think? You might say, what would we need to do in the TI? So let me write this down so it's very clear for you guys here. Go back over here. Actually, you have to see what this is. We're going to copy. You might say, I'm interested in the TI version. Okay, here's what the TI version will say. Right? You're going to get rid of all of, don't get rid of, we got rid of too much. I'm going to get rid of that. Okay. 0, 1.00, a z value. So remember, this is notation-wise the probability that z is greater than or equal to 1.0. That's the notation, or percent. So remember, you have to have a lower value and an upper value, and you're reading this left to right. You're describing what's shaded. So the lower value will be 1, and then you say, Mr. Judge, what's the upper value? Well, that's infinity. You go, what do you mean it's infinity? Because this arrow goes to the right forever. And so I'm going to say to you, I think in my worksheet, if you guys go back and look at my notes, okay, for normal distribution in this setting, what did I say to use? I want to be consistent with what I did on this worksheet. So I'm going to scroll. I'm looking through my notes. I'll tell you what to use. We have to go all the way down. And for a right tail, let's see, where are we at? We're going forever. Whoa, my gosh. Okay, I just used 100. Let's go to this browser. I used 100 here. Okay, you guys see that there for a right tail? So I just used 100 for the upper value. If you guys can see that, and I put that in red. So I used 100. You can use 100. You can use 1,000. It doesn't matter. So let's kind of enter this in our TI the way we did before. So we can get this. Go to second, distribution number 2. The lower value we said was 1. And, you know, I could put 0, 0, fine. The upper value we said was 100, or we can even put 1,000. The mean, make sure, since this is the z distribution, put a 0. Standard deviation is 1. For the standard normal, go down and hit paste. And you should get this value. Now you say, what if I used the 100 instead? I mean, I used 100 by default. I'm going to exaggerate there with 1,000. It's the same answer, approximately. Yeah, it is. 0.1586. Now we're going to go out to the 10,000ths, ladies and gentlemen. So to show you what I did, here's what you want to do, right? This answer is 0.15. Oh my God. 86552596. Go out to the tenths, 100,000. Go out to the 10,000ths decimal place. Look at the digit to the right. It's a 5. I mean, usually I just say, look at the 6, then look at the digit to the right, put your eyeball on there. If that digit to the right, you're going to have to see this now, right? If it's a 5, 6, 7, 8, or 9, you add 1 to the digit in the place value you're approximating. So that's 1.587. This is a probability, but as a percent, that's 15.87%. There's your answer. Is that what we got last time too? That's weird. Oh, no wonder. at least 115. Wait a minute. Oh, yeah. We did get that same answer. Sorry. All right. Notice with the TI, we got the answer as well. Okay, so it is 15.87. Maria, you never have a negative area answer. Your answers in terms of area are never negative. So this is the percent of the population that has an IQ score that's above 100. I'm sorry, has an IQ score above, go back to the original question, 115. Okay. So let's take a look at a left tail. I want to give you guys a left tail. This is question 3. Has an IQ score, we'll say that's less than maybe 80. If you have an IQ score less than 80. Draw a picture of the question. Now remember, the mean here, the center is 100, and this is a real number line, so smaller numbers live to the left. So what I'm going to do here is I'm going to put where 80 would be, then I have to describe less than 80. Well, that's strictly smaller than 80, so that's everything to the left of 80. So they're talking what percent of the bow is shaded here. This is my left tail. You say, okay, a left tail. So these are all, again, x values. We have to convert them to z values. 100 becomes 0. The question is, what does 80 become? So I have z is x minus 100. Here's my conversion formula. We're going to plug in 80. So that z becomes 80 minus 100 over 15. Approximate your z values always to the hundredths because your table goes out to the hundredths. So we can say 80 minus 100, right, divided by 15. We get negative 1.33. So this z-score is negative 1.33. Let's look at the iPad and see that there. All right, we're on our way to calculate a left tail. Remember, at this point, you have to use the z table. You're going to find this percent of the bow this is missing, right? So your final answer will be 50% minus that red portion. We don't know what that is. That's your final answer. It's a left tail. And you say, well, how do I find that? Well, you're going to use symmetry because your z tables are good for only positive z values. So you need the 1.3 row and 0.3 column. So you're going to go to your table. We need the 1.3 row, the 0.3 column, and we have to find what is there. So we say 1.3 row, 0.3 column, ladies and gentlemen. And I mean, that's not straight. So let's draw it straighter. There we go. Let's look at the z table. So we got to go to the browser. We have to go all the way over here. Okay. 1.3 row, 0.3 column. Let's see. Okay, the 0.3 column is going to be this here, ladies and gentlemen. The first, second, third. This is the fourth column. So we know that. Fourth column. And so let's look for the 1.3 row. And here we are. Here's my first, second, third. Here's the fourth column, 0.4082. Okay, it's 0.4082. And that's what we're looking for. So thank you, Maria. You had the right answer, 0.4082. And that's not the final answer, though. 40.82%. That's what's missing here. So 50 minus, we found what was missing, 40.82%. Does anybody know what that difference is, right? If you don't, go to the TI and you say 50 minus 40.82, we get 9.18%. So what percent of the bell is shaded? This will be 9.18%. All right, ladies and gentlemen, and it looks like yes. Both Maria and Marta, right up in here, you ladies, you have the correct answer. Okay, so this is how we handle the left tail. So let's try this out here. Let's see what the TI says, okay? So in the TI, remember, we have to have a lower value and an upper value. So the statement here is, what's the probability that Z here is less than or equal to negative 133? Okay, now read this left to right. Because remember, this is really going to the left forever, ladies and gentlemen. So on the left side, I'm going to use negative 100 as the lower value. And I'm still going to use the upper value of 1.33. So here's what I'm using. Okay, I'm going to do this in the TI. Read it left to right. It's actually a very small number, because if you move to the left, you're getting smaller. So believe it or not, I can say negative 100 is a small number. Negative 1,000 is even smaller. Negative 1 billion is even smaller. You're going to the left. It's a type of small. So the further to the left you go, in that negative direction, the smaller the number becomes. So I'm saying in language, I use a small number on the left, and we go to the right, there's an upper number of negative 133. So in the TI, when I hit variable distribution, normal CDF, cumulative density function, by the way, I use negative 100 down to, what was that? A negative 1.33. These are Z values. Make sure mu is 0, sigma is 1. Paste that in. And ladies and gentlemen, we get approximately the same answer, right? Okay, because if we approximate this to, again, the nearest 10,000s, right? The 7 digit is in the 10,000s position. Look to the right, the digits of 5. Add 1 to 7, and you get exactly what Maria has. You get exactly what Marta has, okay? Using the TI. That's the same answer. This is probability, but it's the same as what they're given in terms of percent. So, we can write that down. Here's what I'm saying for the TI, right? 0.09175, approximating to the 10,000s. Look at the digit to the right. It's a 5. So it's 0.0918. This is a probability. And then move the decimal 2 spaces to the right, and this is a percent. And like I said, we're getting the same answers whether we use the table or whether we use the TI. So you pick your poison. Do you want to use the table or do you want to use the TI? What do you think is easier? Just curious. Is the TI easier, ladies and gentlemen? What do you think? Anybody?
I got a bad feeling about this.
What do you guys think? TI easy? If not, use the table. Then, if not, right, use the table. Exactly. So you might say, I'd rather use the table. Then use the table. Interesting. Table's easier. Huh? We have more practice with it. Yeah, you know what? Sometimes people prefer the thing that you started with, and that's fine. It's kind of normal. Wow, you got interesting. Your table was easier. Huh. Boy, you guys rather use the table. Okay, good for you guys. Well, all my videos on this section here, all the videos, I use the table. So if you get stuck on a question, just look at the video, and there's going to be the table version. I just started doing the TI last semester for people because some people had it and blah 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 blah. Okay. So anyway, ladies and gentlemen, here's kind of how we go about this example, and there's more examples to go through, but at this point, I always think it's smarter to change the setting on people. Because if you only work with some settings sometimes, because really all you need is one setting in great detail and you can apply it to all the other settings. But, sometimes some people think the mean is always 100 and the standard deviation is always 15. So if I go to the browser and I say to you, even though we've been using this table, playing what percent of the ballot shaded, historically how I've done this, where did I go? What did I do here? Oh, yeah, here we go. Statistics lecture, go down here. 12. I'm gonna take one of these settings here. Look at number 5. Okay, if you guys can see that there, number 5. I'm gonna try that out. So in number 5 there, they're saying the incomes of trainees at a local mill are normally distributed. So if you're looking on the web at number 5, they're saying incomes are normally distributed. Okay, now what do they say in number 5? With a mean of $1,100 maybe per month and a standard deviation, although they don't put per month, and a standard deviation of 150. What percent of trainees earn less than 900? And so here's my question. What percent of trainees earn, question 1, less than $900? Okay, so that's the question. I'm going to write this down. I wrote it down in the iPad, and I'm going to change this to. I'm going to say question 2. At least $1,000. And these are questions. All right, let me do it here. At least maybe let's see, you got less than 1,000 or less than 900. Okay, we'll say at least 1,000. That's fine. No big deal. Question 3. No more than $1,250. Question 4. More than maybe 800. Question 5. Between 800 and 1,250. This is money, right? And question number 6, we're going to say, how about between 1,250 and 1,500. Yes, ladies and gentlemen. So what I'm going to do here, these are some questions here. Now we say, what does this mean if we start this off? We're saying what? Incomes are what? Normally distributed. And the mean is 1100 and the standard deviation is 150. So here's essentially the first kind of question. We say draw a picture of the question. Right? So in the center here, we got this real number line. The center is the mean. And the mean in this example is, let's see, what's the mean? $1,100. So I want to write this down. That mu is 1,100. Standard deviation is 150. So in the center, we have 1,100 here. And let me draw a nicer bell. Now, a picture of the question. You say, oh, my question is less than 900. So where does 900 live in relation to 1100? It's to the left. So 900 is here. And they're saying, oh, it has to be less than that value. So numbers less than 900 live to the left of 900. They want to know what percent of the bell is shaded. This is a left tail question. Okay, so it's a left tail. So the center, remember, these are all X values on top in blue. We got to convert, and the mean is always 0. So the question is going to be for us, what does 900 become? So Z would be X minus, now we need the mean. This is a different mean. It's 1100. Standard deviation is 150, ladies and gentlemen. So we're going to convert 900. So that means 900 minus 1100 divided by 150. Approximate your z-score to the nearest, right? To the nearest hundredths. And let's see what happens. Clear. 900 minus 1100 divided by 150. And yes, Maria is correct. Negative 1.33 again. Okay. Yes. So that z-score is a negative 1.33. I got a little deja vu here, ladies and gentlemen. So negative 1.33. Did we do that one already? Yeah, we did. It's the same as question 3. So 9.18%. So it's the same as question 3. Okay. Was that 18%? Yeah. How boring. But remember, you use your table here. Let's go back. 9.1. What was missing? 4082. So I want to go back and remind people, use your table here. 4082. This portion's 40.82% right in here. What's missing? Yeah. Okay. So anyway, that one's the same. So fine. Look at least 1,000. So if you said to me for the next one, at least $1,000. Okay. Draw a picture of the question. The center this time is 1100, right? We're drawing a bell. $1,000 is still to the left. 1,000 in relation to 1100. So 1,000 is to the left. Now you have to know the meaning again of at least 1,000. That means 1,000 or more. So it's all these values here, ladies and gentlemen. And 1,000 or more is the values to the right. So they want to know what percent of the bell is shaded in this case. This is a bit more interesting now. Okay, and these are all, again, the X values. The question's going to be, convert these to Z values. So I'm going to have to convert the number 1,000. So we're going to use our conversion formula. Z is X minus 1100 over 150, and x is 1000. So z will be 1000 minus 1100 over 150. Let's approximate this. Okay, we got to approximate it to the nearest hundredths. So we get 1000 minus 1100 divided by 150. Boy, what boring problem. Negative 0.67. It's not always these values. It's kind of a weird day. All right, well, fine. We'll just see how this works. So this will be negative 0.67. So remember how this works. I know this portion is 50%, but you know, deja vu, we had this one already. So 0.67, we have to use the positive values. I'm going to go all the way back and find it. 0.67, maybe number 1. There we go. Negative 0.67. You know what this is? Right here. 24.86. We already found that one earlier. So I'm going to use that. I'm going to say copy. Now you say, where does that go? That goes right here. Uh-oh. I bet you it didn't copy it, so let's get it again. Here we go. $24.86. I knew it. I didn't want to get all this. 24.86 goes right in here. So what do you do with these areas? Do you guys remember? What do you guys do with this area? Anybody remember? Do we add? Do we subtract? Do we multiply? Do we divide? Okay, thank you, Maria. Thank you so much. You add them. Absolutely. So you got the left portion plus the right portion. 24.86 plus 50. Okay. And, you know, I know you guys can do this arithmetic. Final answer is 74.86% of the bow is shaded. So this portion is 74.86% of that bow. Right, Frida? Right, Alexandra? Right, Maria? 74.86. There you guys go. Easy, easy, easy. So here's what I'm going to say to you guys. We've done, you know, the first two. I'm going to give you guys time to do the next 4, meaning 3, 4, 5, and 6. We'll give you guys some time to do that. And then we'll give you your break time. Okay, so I want you guys to work on this yourself. And we'll give you your break time. So I'm going to say here's 1, 2, 3, 4 questions. Yeah, let's do 35. Or 36. Okay. Try this out. Let's see what you guys get. Okay, everybody, welcome back. Let's take a look where we're at here with everything. And welcome back. Okay, we are on all right, we're looking at question number 3, no more than 1250. So question 3, no more than 1250. So what you guys want to do is draw a picture of the question. Right? You have your bell. $1,100 is in the center. 1250 is to the right. Now, no more than is actually short for 1250 or less. So we're going to have to shade things that are, less 1250 or less, and that's going to be this portion of the bow. Okay, so 1250 or less, ladies and gentlemen, that's no more than 1250. Okay, and again, these are X values. We want Z values now. So the center is always 0. So here we get Z is X minus mu, which is 1100 over standard deviation of 150. Now we have to convert this number here, 1250. So we're going to have to convert 1250. 1250 becomes the following Z value. $12.50 minus 1100 divided by 150. And we get 1. Oh, okay. So the Z-score here is 1.00. Okay, that's pretty good. So let's ask you guys this question. What'd you end up getting here? Excuse me. Remember, the portion to the left here is 50%. We need this portion here. Okay, from 0 to 1. Now, since we already have that, let's go back and use it. 1.00. Let's find out what that was here. There we go. 34. Here it is. 34.13%. Thank you. So 34.13% goes right up in here. Okay, and we already have somebody saying, guess what? You're going to have to take that, 50 plus 34.13. And yes, you'll get 84.13% of the bow. So, what that means is 34.13% of this situation incomes, right, are no more than 1250 or 1250 or less. So you're right. Thank you. This is how we get the answer. Okay. So thank you, Alexandra. Okay. Anybody else get this 84.13? All right. Anyone else? Pretty good. Okay. Number 4 now. They're talking about more than 800 now. So more than 800. The incomes are more than 800. So when we draw a picture of the question, right, here we go. More than 800. $1,100, 800 is to the left there. More than 800 is greater than 800, so all the values bigger. Okay, so all of these again are X values. We got to convert them to Z values. The mean is 0. The question is, what does 800 become? Going to find this value here, 800. Right, as a Z value. So we say Z is x minus 1100 over 150, and that's 800. 800 minus 1100 over 150. And here we go. 800 minus 1100 divided by 150 is actually negative 2.00. Okay. So we're going to see what this is. Let's write this down. Negative 2.00 now. So we're going to use the z table, but remember, this right portion is 50%. We need to get the left portion. So for the z value here of negative 2.00, remember what we do. We get the row, and it's going to be, you know, we have to look at the positive z-score, you know, because we don't have a table with negative z values. So we have the row, and then we have the column here, if you guys remember that. So z 2.0 row, 00 column. All right, so we have Maria saying it's 4772. Let's go to the browser. Let's find this on our table. You guys said you like those tables. Good. Here we go. 2.00. So we're going to find that z table here. Now remember, that first column up here is going to be our 00 column. So we just need the 2.0 row now. So yeah, there we go. See, that first column is 00, so we need the 2.0 row. And yes, it looks like Maria's correct. It's right here. This is going to be 0.4772. Okay. Right, so we have 2.0. It's right below Maria's picture there, if you guys can see that. And there it is. So, ladies and gentlemen, this portion here is 47.72%. So we add, because we have two sides, right? The left side plus the right side. So when we add those values, we do get 97.72% of the bow is shaded. Okay, because we're going to take the 47.72 and we add it with the 50. And let's see, Alexandra, you're correct for the final answer. Okay, so it's going to go there, 97.72, right in there. You guys can see that. And there we go. That's number 4. Great, we're almost there. And let's see, what's number 5 going to be? So number 5, between 800 and 1250. Okay, let's draw a picture of the question. Okay, 1100's in the center, and the question's going to be now for number 5, between 800 and 1250. So 800 is going to be to the left, and 1250 is going to be to the right. Okay, so between these two numbers, this is between, so we're going to shade this portion of the bow. So here's a picture of the question. And these are X values. Okay, so we're going to have to convert 800. Here's the values. We're going to convert all of them, but we already know by now that 1100 is always 0. We convert 1250. I think we've done that before. So let's look at 1250. Yes, it's 1.00. Right here. Okay, we already converted that one, so you guys can see it. So we know this one's 1.00, and I believe we just converted 800. So if we start to say, well, what about the 800 value now? What does that become? when we convert it. It looks like 800. We already did that here. It's negative 2.00, right? Okay, so there we go. Now, we used tables already for each one of these. So the prior answer was the 2. This is 47.72%. We already, it's still here. We can see that, right? And then for the 1250, that's right up here, 34.13%, right? So we're going to add that 34.13. So you're going to take both of these answers and you're going to add them. So you can add them. $47.72 plus 34.13 becomes 81.85%. So, all right, 81.85. Let's write this down. So here we have 81.85%. And that's question 5. So it looks like Alexandra, yes, you're correct with that. And Maria, you're correct with that too. I'm trying to see what we can do. We can fit this in. You know, so we got 2 correct answers, 81.85%. So, you know, Marty, you want to be careful. That's 81.25. So be very careful. But anyway, ladies and gentlemen, there you guys go. Not too bad, right? This is how we do number 5. So, okay. On our way. So look at number 6. Number 6 says the following. Right. Number 6 looks like we're at between 1250 and 1500 now. Okay, number 6, between 1250 and 1500. So let's see if you guys remember how to do this. 1250 and 1500. $1,100, and remember 1250 is to the right. And 1500 is to the right. Remember, these are all X values, so we need some Z values here. The center is 0. 1250, I believe we did 1250. Did we do 1250? Yes, we did. That was 1.0. And now we have to convert the next value, 1500. So with our conversion formula of Z being X minus 1100 over 150, when we put the 1500 in, that means it's 1500 minus 1100 over 150, which is 400 over 150. Remember, we approximate to the tenths. What's that Z value? Anybody know? Let's find the TI. 400, right, divided by 150. Go out to the nearest hundreds. That's 2.67. To the nearest hundredths. 2.67. All right. Yeah, Maria got that same Z value here. Okay, good. And let's do this. Remember what we have to do for this question here. Remember what we did last time. I'm going to do this straight line here. It's not straight. I need from 0 to 2.67 and then minus what is missing. What's missing, we already had in the prior question. What's missing from 0 to 1 is 34.13%. So this portion is going to be 34.13% there. That's missing. If you want it to write it here, you can. But what you need to also know is what percent of the bell is between 0 and 2.67 that we just found down there. That's what's going to be compromise or comprise, you know, that area, the percent of the bow. So 2.67, we need to look at that as a Z value. We need to roll in a column again. We got to use the table. So this is going to be the 2.6 row plus the 0.07 column. So here's the Z table. And you have 2.6 row, 0.7 column. Okay, so we're going to look at the table now. Browser, 2.6 row, 0.7 column. So the 0.7 column is like the third to the last. And then you need the 2.0 row. So I see 4808. Let's double check here. Okay, double check. Is that, no, it's 2.67. Oh, already all the way down here, 2.6. 4962. So let's double check see if you guys can see this. Yeah, 4962. So it looks like, who do I have some agreement with? I think Maria agrees. Let's put this close to, this is a 2.6 row, 0.7 column. Yeah, 4962. So see if you guys can see that there a bit better. 4962. All right. Thank you, Maria. 4962. Okay. That's not the final answer, right? So we found the percent of the bow that's between 0 between that 0 and 2.67, but 34.1% is missing, so we're going to subtract that. So you're going to look at this in the TI, we subtract these areas. And that's going to be 49.62 minus 34.13. 15.49%, double check. Okay, 49.62 minus 34.13, I get 15.49%. So remember what we're doing here. If we can find some space. You're taking the 49.62% and you're going to subtract what's missing, which is 34.13%. And ladies and gentlemen, when you do that, you end up with a 15 point, let's see what the TI said, 49%. So in here, this is 15.49% of the bow. So double check. This is the last one, number 6. So I'm getting some different answers here. Look at this here. 83.75%. No. Yeah, 15.49. That's as a probability, but as a percent, it'll be 50. You know, that's a probability value, Maria. 0.154. If you go to the nearest 10 thousandths, that will be 0.1549. But they asked you percent. The language is percent, so that's 15.49%. So remember, Maria's answer is a probability, 0.1549. The blue answer is percent. So if you remember the relationship, okay, here we go with Maria. Okay, and yes, Angela, we're going to subtract. And I'm going to say we have to check the syllabus. Okay. If we have class on the 24th, we check the syllabus anyway. Yep. Maria gave the probability answer. Yes, Angela, we subtracted. And what do we say? When do we know when to add and when do we know to subtract? The most common question. It goes back to the exercise in grading on a curve. In one case, you have missing area. And when you have missing area, you subtract. Remember, this portion is missing, so you take that away. That's why we have subtraction of that. And you say, I take it away from what? I take it away from the 4962. Now, that's essentially the answer. Now you say, what about adding? Well, if you have a left side with the right side, since it's implied, what percent of the ballot is shaded? You know, everything in blue is shaded. So it implies that you have to add the left portion with the right portion to get the total. Because they want to know what's the total percent of the ballot that's shaded. That's when they ask generally what percent of the ballot is shaded. So that's an addition problem here. So I would say you definitely need to know when you're adding and subtracting completely, and it's completely based on the picture that's in front of you. So, you know, we do have, like I said, I do have that worksheet here for you guys, if you guys remember the worksheet. And where's the worksheet here? Go to the browser. There's your formula sheet. But, you know, the worksheet that I did is in the statistics transition down here. So we went through all of the knowledge here in this worksheet, ladies and gentlemen. And we went through all the whole lecture there. So if you have to review this, what percent of the ballot is shaded game, then please do it. You also have the format for TI, by the way. So you have all these here. So I went through some extra work here for this to show people. I went through an IQ situation, but I did the TI for people for the IQ scores. So I'm showing you what to enter for all these questions. You can try this out and get the answers yourself if you want to go the TI route. But sounded like you guys like the table. Oops, sorry. So it sounded like you guys actually like the tables because that's the answers I got. So anyway, let's go back here to the iPad Pro. Now, you said, how did we get 34.13? We got that already earlier right up in here. Right here. This question. We need to know from 0 to 1.0. This is a Z-score. So from 0, well, this portion of the bow is what they're talking about. We already found it in a prior exercise. It's 34.13%. That's where it came from. All right. So what I'm going to do now is this, ladies and gentlemen. I'm going to actually go through your book and give you some bookwork and web work. So we have some web work and book work. And if we go to the browser, remember we're looking at element, I think it's Statistics Lecture 12. Yep. Statistics Lecture 12, I'm going to say you guys are going to need to do for now 1 to 10 all for now. But, you know, there's going to be some book work as well. So I'm going to give you the book work and now update all this in Canvas. So what we could do now, ladies and gentlemen, again, as I look for your book work, you guys can start printing your name. I already know I did that already, but I actually finished it. So you guys can start printing your name here as I go through your book and give you some book work. And you want to do both, remember? Your book work and your web work is what enables you to do very, very well. So print your name, ladies and gentlemen, in the comment section for attendance purposes as I go and get your book work. And I'll post this in Canvas. And you guys stay safe and you have a great day.